again, what we're looking at again is connecting nature's puzzle. And again, first of all, if you don't mind, some selfless self-promotion here. Again, if you are not part of my Capital Naturalist channel, I ask that you guys, go ahead and participate. I have 4 different options. I mean, we have the Facebook group, of which I have about 10,000 members. I have about 600 or so different kinds of videos on the YouTube channel. I have a regular blog. I wish it was more regular as well. And of course, I try to get what I can on Twitter. So again, I invite you guys to contact me. My phone number and so forth is there. And I look forward to hearing from you either through the social media or on some of these other things. But first of all, back to piecing together nature's puzzle. And I think right now, and we'll look at this over and over again, I'd like to kind of give you my theory about how I view as a naturalist the world. And I view the world such that every different piece is kind of connected to something else. Now, there's some really neat things about it. If you study anything about nature, you can't help to realize that it's connected to something else, and it just leads you down the road into more and more of these things. A lot of this starts with the plants and why they grow in certain places and all the things associated with them. And we'll see that over and over again as we do. Now, there are some important rules about, again, a nature puzzle. If you have a nature puzzle, you can't lose any of the pieces. If you lose too many pieces, you lose the integrity of the actual puzzle itself, and you're not able to put the puzzle together. And unfortunately, we're losing pieces all the time, as we'll see through here. The other thing is, if you do have a puzzle, you don't take another piece from another perfectly good puzzle and shove it in there, because if you do, now other pieces don't fit. And that's what happens when we introduce things like invasives and so forth into an area. And again, we'll illustrate that as we go along. So again, most of you guys, when you went to school, you probably learned about the food chain, and you realize, okay, this feeds on that and so forth and so forth. And then we find that that is just too simplistic. So then people came up with this food web, how it's more interconnected one way or the other and this and that. Again, not as simple, but even this really does not cover how interconnected the real world is. So it's true out there that it might be a snake eats frog world out there, but very easily it can be changed around. Here we have again a northern water snake eating a bullfrog, but you look down below and here is the bullfrog eating a northern water snake. Again, folks, things are not as simple as what they look, and that's one of the things we'll be able to look. We'll be looking at today. So John Muir, one of the first great naturalists, he basically said, when we try to pick out anything by itself, we find it hits to everything else in the universe. And again, that is something that we'll see over and over again in this presentation and in the natural world. Sorry. So one big thing, and I think people may be aware of this or not, is an old saying amongst naturalists. Naturalists have all sorts of different ways to kind of memorize things. And in this case, when an algae takes a lichen to a fungus, and in most cases, not all, there are some other combinations, not just fungus, but cyanobacteria and things like that. But it's algae together with the fungus that makes up this brand new life form, which is a lichen. And again, the lichen and the algae cooperate with each other. One produces some of the energy that it needs, the other one gives it a place to stay and so forth. And so by themselves, an algae and a fungus are not the same, but when they put together, they can take advantage of a brand new niche, and they form this new series, something called a lichen, of which there's many all over the world. So again, just shows you how combined together, they can take on brand new niches and brand new places in the universe, as it were. Any other thing, and I'm sure if any of you guys were here, of course, and listened yesterday to Serenello's talk on basically fungi, the idea about mycorrhizal fungi. And we find out that about 90% of the world's plants have a positive association with fungi. This is kind of strange because when people think about fungi, they gardeners and things like that, think it's a bad thing. But there are fungi and plants that cooperate together. And in fact, 80% of the plants don't survive without this association with the fungi. The fungi attaches it to the bottom. It can lead to, it can stretch, and so they can get more water and nutrients from a further area. There is a belief that they can share amongst each other, so that a small tree can rely more on stealing nutrients or something like that from other places. So again, mycorrhizal fungi are very, very important. And in fact, some things, especially some of our native orchids, can't survive without the fungi. The lady slipper orchids, both the pink and the yellow, and a few of the other different kinds of orchids that we have, are very dependent on certain type of mycorrhizal fungi. If that certain fungi is not in the ground, then this plant can only survive for a very short period of time. which is unfortunate because I've seen this before. People come by, and I was unfortunately in one place where a, a, a group of people came by and they basically dug out all of the lady slipper orchids in the foolish belief that they could take them home and it would grow for them. But when you separate this from the fungi and so forth in the ground, then unfortunately, the plant is not going to survive very long. Even if you got a ton of the soil in with them and there's lots of fungi in there, in reality, if the fungi does not survive in your new garden that you put it into, both the fungi and the orchid will die. And so again, it's very dependent on the certain types of fungi for this thing to grow. And that's true of many, many different plants, but this is just one example of this, the different kinds of lady slipper orchids. And then you have things that make things even more complicated. So here are a bunch of plants that people used to think were parasitic on certain kinds of plants. So for example, over here, when you look at the, I keep doing that. When you look at the pine sap, people used to think about it and say, oh, guess what? Pine sap, because it always grows near pine, therefore it's parasitic on pine. Same thing with beech drops down below. It always grow near beaches. It must be parasitic on the beaches, and so forth and so on. Many of things with things like oaks and things like that, with Indian pipes and squaw root. But the reality is, it's not so much that it depends, it's parasitic on that plant. It's actually that these are different kinds of plants that actually are parasitic on the mycorrhizal fungi that grows with these. So it's really a three-way type of thing, a menage a trois, as it were. These are what they call mycorrhizal cheaters. They don't steal, the beech drops don't steal from the beech. They steal from the fungi on the beech. And so for this plant to survive, it actually does not, it needs both the beech and it needs the fungi that is on the beech that it depends on. And this is true of all of these. If they don't have these certain kinds of fungi associated with their particular plants that they grow on, then these plants don't survive. But here's the problem with this, and that is that sure, underground you can survive. You can steal some food from the fungi that's stealing it, I guess, from the plant itself. But you have to get pollinated. And so once a year, these things come up above the ground, and then they flower in the hopes that some kind of pollinator visits them, and then they can disperse the seeds that way. And again, it's a wonderful type of thing, and there's all of these. And by the way, on the bottom right, this is the first time I've ever seen a fall coral root, and luckily I was hunting just a few weeks ago, and I happened to see this, and it's a first for me. But here is another very, very cool plant out there. And again, the only reason it grows is because it needs a certain fungi that are feeding off of the tree roots. So again, moving on, we look at something else, and here's what they call a hemiparasite. Not a true parasite in the full sense, but it is parasitic on a plant. So this is mistletoe. And in our area, and again, it depends on different kinds of areas, and so people are studying why it's in some places and not the others. For us, it's mostly maples that grows on. But this plant, mistletoe, it actually grows on the plant itself and gets its nutrients from the plant, from the maple tree in this case, in most cases. But it still is, it's still photosynthetic. So it's stealing some nutrients, but it still makes foods for itself because it is green. It can make this energy from the sun. And again, a very neat little type of plant. But by surviving this way, one, two different things. One, it can get nutrients from the plant itself. But the other thing is, this way, this plant gets way up above the ground where there's more light and so forth. So it doesn't have to waste any energy to forming this big, long stem, a trunk like a tree would. It's basically using its host to do that. So again, it's not a true parasite in one way because it's making its own food, but it is parasitic in another way because it's still stealing the nutrients from the food it's on. So it's what they call a hemiparasite. And again, there's lots of different associations like this, but I mean, there's parasites, there's parasitoids, there's all sorts of different things. And by the way, parasites, very loosely translated, they don't usually kill their host. So somebody might have a parasite on them, okay? But that parasite, unless it's either the host is very weak or there's so many of them, it doesn't usually kill its host. On the other hand, they have parasitoids, and parasitoids, they always kill its host. And parasitoids are things like different kinds of wasps and so forth. They kill the host, and so that's a parasitoid as opposed to a parasite. So as we move on, I'd like to look at this, and all of the things that I'm talking about depend on plants. And on the left-hand side, you got Talame's list, and again, this is data. Like for example, Quercus right there, the very first thing, oaks. It lists that supposedly it's 534 different species of caterpillars it supports. In reality, it's 557 they found out so far. So this is a little bit dated. But again, you get a lot of these things. These are what they call keystone species on this, on these few species, and about, most of the most of the insects in the world survive on just a very few 14% of major plants. These big plants support so much more. And so these are the big ones. Now, if you look at these plants and how important they are and how many caterpillars they support, that's great. Now you look to the right, and here are some common plants, both woody plants and some non-native perennials. And if you look at them, the number is incredible. Some of them support nothing. In many places, people plant zelkovas, and that's, they plant it because, oh, it's this disease-free tree, this and that, whatever. But in reality, it supports nothing. Same with ginkgos, it supports nothing. So it's sure it's in there and it's there, but in reality, if you have a native plant, it can support so much more. And you can see just the discrepancy on how many more things it supported on these plants to the left, the native plants, as opposed to these things which we've introduced, which really support almost nothing. So folks, if you want to support and continue with this puzzle, you got to plant the right things to connect to other pieces. And those are the native plants. The non-native plants, they connect to very, very little. So they support very, very little. On the left, the native plants, which evolved with the native insects and so forth, they support a lot. So one of the best things that most of us can do is to plant locally native plants, not cultivars, not things that we choose what they look like, but what the insects evolved with. That's what they chose what they look like. So folks, if you want to do anything to really support wildlife, the best thing that you can really do is really plant native plants, all right? I'll get back to this, but you get the idea. So again, if you look at it, and we looked at caterpillars for a very important reason. They're big and common, it's something like that. But if you look at it, 96 of the terrestrial birds feed their young caterpillars, and in some cases sawflies, which are related, they're related to wasps and so forth. But regardless, they look like caterpillars. That's their major food source. They're basically big protein packets for the newly developing young. And so while these birds are nesting, even things that we normally think of as feeding on other things, like hummingbirds feed their young all sorts of different kinds of insects and stuff as well. And even things that we think of as coming to a bird feeder, in reality, they really feed on caterpillars. That's what they need for them to survive. And then all 18 of our native bats, they all feed on insects, especially moths. That's the big thing that they feed on. So folks, when we plant something like this, and you look up above, something like an oaks, and it supports 557 different kinds of caterpillars, those caterpillars then feed all of our bats, as well as 96% of our land birds. It's an important thing. One little tree is a big important piece of the puzzle. And if we lose that tree, then everything that it supports is also risk being lost. So folks, it's pretty important. And to bring down even closer to this, you look at this. Here's a Carolina chickadee, and it takes basically a little over 9,000 caterpillars to raise one brood of 3 little nestling chickadees. So studies have been done, and studies right nearby in Baltimore and so forth, and they found out that if 70% of the biomass on your property, or within the range, I should say, of a caterpillar, so of our neighborhoods, if they're not native plants, then the chickadees cannot survive. I mean, if it's less than 60, most of them die. Some of them try to feed off other things like spiders and so forth, but spiders are not the same kind of food. So there's very fewer nestlings survive. They're all lesser weight. They will not sustain a population, and 70% of what you have on your property is native. That's the big thing. You put the native plants and you support this. You don't have native plants, and no matter what's there, they die. On the left-hand side, chickadees, they come to my feeder all the time. When they did this study, and the trees on the property were not native, but the chickadees were still nesting, they went over and they found that the chickadees, the babies and nestlings had died. But when they looked at them, their crops were full. What were they full of? Seeds. So the chickadees, their parents tried to feed them something, and all they could find were the seeds, but the seeds were not enough to feed them. They had full crops, but the animals were dead. Why? Because they don't need seeds. What they need is good protein in insects, and in most cases, these are caterpillars. Okay, folks? So if you really want these things, you want to do something, try to get at least 70% of what your yard, the biomass there, to be native. And then you'll actually have these guys have sustainable populations. Okay? So again, that's the big point that they bring up, in Bringing Nature Home and his latest books as well. I mean, this is the whole idea that if we really, if you look at it, and let's look at where I work, Arlington, where, we, most of the area that we have, 40% is impermeable. Of all the lands that we have, natural lands make up less than 4.4% of the land that we have left in Arlington. And of that, county parks, of which I work for, we only have 1.7% that we control. Now, if you think about it, could all the wildlife survive on 1.7% of the natural lands? Of course not. So folks, people like you and me and everyone else who plant native plants on their property, they're the real gardeners that are really that can support the whole food chain. We plant native plants, and that supports everything else. It's so much important, very important for gardeners and homeowners to plant native plants because it supports everything else. So when we want these things, we want it to exist and so forth, planting native plants is one of the best things we can do. There's other things too, but that is the best thing that most of us can do. So let's look at something here. Here we have a mighty oak, okay? And I already mentioned 557 different kinds of caterpillars feed on here. But not just that, there are over 550 synapsid wasps, gall-forming wasps on this, 37 tree hoppers, 12 leaf hoppers, 61 wood-boring beetles, 60 plus birds that feed on them, and 40 plus mammals. All of these kinds of things feed on oaks. So folks, if we lose an oak, when we lose oaks and something happens to them, all of these other things have a harder time surviving. And for many of them, there's over 600 species that have to have an oak. Without the oak, they're dead. It's not like a squirrel that, yes, they can go find other things to eat, but many of these caterpillars are host specific, as are many of the gall-feeding wasps. So if you lose this piece, you lose the oaks, you lose all of these things tied to them. That is an important keystone species, as Talamy likes to call them, an important piece of the puzzle that you never want to lose. You lose the oaks, you lose all of these things that are tied to it. And that's what I mean by nature puzzle. Okay, folks? So again, when you look at these things, you start thinking of Lepidoptera host plants, caterpillar host plants. And, people understand that, yes, we can plant these things and it's great. You plant this and most people plant it because they want monarchs around, which is great. But in reality, you don't just plant it for the monarchs. In reality, all of these other kinds of animals also live on milkweed. Some are native, some are not, most are. But again, when you plant milkweed, even if you did it because you wanted to seed the monarchs, in reality, what you're doing is you're helping out all of these things. So when you plant something like an oak tree or something, you may not ever notice all the important things that depend on it, the other pieces of the puzzle. But believe me, they're there. And if the oak disappears, they disappear. Much as if you take out the milkweeds, the monarch will disappear. Folks, these are all interdependent. They're all interconnected. So yes, plant these things if you want to, milkweed because you want to get the monarchs. But in reality, you're supporting so much more. And that's the important thing. Now, so we go on to another different aspect, and it's pollination. So about 3/4 of the world's plants need some kind of animal pollinator to move the things there. And nothing is a better pollinator than bees. Now, there are tons of different kinds of bees, and it's true that a lot of our food depends on bees, but it's not just honeybees. Remember, honeybees were introduced in 1627 in Jamestown, okay? They were not originally over here. Before people brought in honeybees, all these plants continue to survive. In fact, when people brought in honeybees, now they had a competitor that they had to deal with. So folks, we need honeybees for our own agricultural purposes, and we need these kinds of things. But again, everything depends on pollinators. The pollinators, I should say, are what many of the plants depend on for them to produce different kinds of seeds. Now, if you look at this, though, everyone thinks of European honeybee, but we have here in both Virginia and Maryland about 450 or so bees, okay? Most of them never heard of them. They don't know anything about them, but these are the native bees that have always evolved here. And about 1 out of every 5 of these are specialists. They depend on one group of plants for them to survive. But they are what they call oligolectic plants. If these plants are not around, they may be able to get nectar from another place, but they cannot reproduce. So here is a listing of some of the plants that we have and some of the specialist bees that depend on them. And that's important because if you wanted to support all of these kinds of bees, you got to have the right plants there for them to survive, because 1/5 of all the bees depend on particular plants. And folks, that's pretty important to realize. Everyone hears, oh yes, that honeybees are disappearing and stuff like that. We know very little about some of these, some of our native bees, which may or may not be disappearing. And we know they disappear when their plants aren't planted, okay? If they're plants that they depend on, that they need the pollen in order for them to reproduce, are not there, then the bees aren't there as well. In fact, people who study bees, they look for these plants because that's the only place they can find these particular bees, okay, folks? So just like there's caterpillar host plants, there are bee host plants. In these cases, what they call illegal lectic plants that they depend on, okay? So let's look at this. So most of the bees, 70% of them live underground and another 30% live in trees and burrows and so forth. So we're gonna take a look right here at just one example of this. We're gonna look at mason bees. So here's a mason bee. The mason bee goes out there, collects a bunch of pollen, some nectar to it, puts it all together in what's basically a little pollen ball, and there lays, on the right-hand side, you can see, lays an egg, okay? So the egg is laid on there, and that's great. And then it seals it off, and it continues making more and more of them. The females all in the back, and the males more toward the front. When you finish this off, you got these long, long layers with the females all the way at the end, and the males up at the front with an empty chamber in the front, so if something breaks in, they don't get anything, they don't really get anything. But when you put this together, this is a valuable food source. So I used to do some experiments and things like that with mason bees and so forth, and it was amazing because yes, I knew there were mason bees and sometimes other kinds of tunnel needing type of insects, like different kinds of paper wasp. I'm sorry, different kinds of wasps, things like that. But in reality, there are other things that I discovered there. So for example, here are two kinds of cuckoo bees. On the left is one kind of cuckoo bee that sometimes goes into the mason bees that live in trees. And so what they do is they wait for the bee to leave. They go in there and lay their egg right next to where the other, where the host bee has already laid its egg. And when they hatch faster than the other bee's egg, they eat the egg and then they feast on the pollen that someone else has collected for them. On the right is a ground nesting cuckoo bee. Same type of thing. And again, these aren't really good for pollinator or things like that. They have very small hairs and they're very thick bodied because it can be bad if they're laying their eggs and mama bee comes by. So they're armored so that they can survive some of these onslaughts of when the mom tries to discover them. But much like European cuckoos lay their eggs in other birds' nests, we have several kinds of cuckoo bees and also cuckoo wasps that lay their eggs in the nests of others. They don't collect the pollen, they actually steal somebody else's pollen. And here are two examples of cuckoo bees, one that lives underground and then one that lives overground. So then you have this. Here we have a pollen mite. And the thing about pollen mites is that they're all over the place. In this case, this is a male mason bee, and it's badly infested with these pollen mites. They basically sit on a plant and wait for a bee to come by, and as they come by, they hitch a ride on it, and they feed off of the bees. This is an extremely, this one's very infested. 1 or 2 pollen mites, not a big deal. In this case, this was a bee that was probably in there, and as it walked through its different containers, more and more pollen mites pollen on it. So sure, you planted maybe, or you had these things and you put up some kind of boxes or whatever for mason bees, but what do you get? You get cuckoo bees and you get pollen mites, and you sometimes get parasitic chalcid wasps. This is a cool one. This is Leucospis affinis. It's a really cool looking, one of the larger ones. And in the back, you can see what it's long. Can you see it kind of going into the wood? It's got a long ovipositor, a stinger, if you would. And it drills that stinger into the cracks until it finds where a bee has already nested, and it lays its eggs next to the bee, so it eats the bee and its pollen stores. So this is a chalcid wasp, and you can see here, you have to really look at it, but it's actually drilling into the wood to get it. So that's one kind of it. But at the same time, here's another kind of chalcid wood. This one's small. Here's a hole where a normal little bee can come into, and these little tiny chalcid wasps go in and out. Again, it's got a stinger. It goes in there. It stings the thing, lays its eggs. And so there you go. So folks, if you were like trying to deal with these kinds of things, you're planting something, you're trying to raise, in this case, mason bees. In reality, there's a whole other things that depend on them. And we made it easier because we put all of these things together. Normally, these are solitary bees, so they nest in one place and then another. But if you put all of them together, you can build up huge amounts of these parasites that live on there as well. And then, and I forgot to mention one other thing. And with these other things too, I stopped doing this because I found that the more I did this, the more and more that I ended up finding two kinds of Japanese longhorn bees, which were introduced to kind of pollinate and so forth, but they're not native. And soon I was only raising non-native bees. And yes, they're bees, but I was really trying to raise the native ones. And so I stopped doing it because all I was doing is supporting a non-native thing which competes with them. They compete for the holes and they compete for flowers. And I'm like, well, I'm not helping our native population by doing this. So I stopped doing that. So the other thing, and I've mentioned this before, is myrmecoccary, where the plant helps the ant. And if you see here, you got two of these ants. These are in a genus that they call Aphaenogaster. But anyways, they're pulling off, as you can see, what is a cover on the seed. And this cover is basically what they want for it. But when they go to feed this, they actually take the seed with them, and they tear off the edible portion, and they leave the seeds in their basically their trash mounds. And their trash mounds are pretty neat because guess what? Those trash mounds are very rich and so forth. So thus, the ant helps the plant. It takes the seed, it puts it into a very rich place, underground, planted, and protects it. So it's pretty important. And when we find out that even though only 5% of the plants are myrmecoccous, that's what you call this. These are ant-dispersed plants. Only 5% of the world has these kinds of things. But in our area, in the mid-Atlantic, we're one of the hotbeds for myrmecoccous plants. So there may be about 11,000 of these things worldwide, many of them in places like Africa and so forth, and limited populations. For us, we're in a place where 30% of our spring blooming plants depend on certain types of ants to move their seeds around. And this is just an example of some of them. So folks, there are a lot of neat things that are all interconnected. And again, this is just one of them. And I think from last time, some people realized that there are a lot of really cool connections with plants and other animals. You got ant cows, where an ant tends to a different kind of aphid or something like that, protects them from predators, and they get rewarded by some of the honeydew that these things produce. So it's pretty neat how ants are connected to so many different plants. In this case, the plant helps the ant by giving them something nutritious for them to eat, and the ant helps the plant by moving the plant and burying it into a nice rich area. This is how they help each other out. And it's interconnected. You lose one, the other one doesn't do as well. So people have talked about this big insect decline, how worldwide it is, and things like that. And I'm going to say a couple of things. And this is it. One, in some of these places, you could kind of see this, and I know I use this for a lot of different slides, so I apologize. There's a lot of extra information in here. But in many of this, there's a reason why the animal is rare. It's rare habitat. And if the habitat's gone, well, of course, the animal's not going to survive. And many of these, especially these aquatic types of insects, if the water is dirty, if it's affected, then those plants, those animals don't do. But many of them are very particular about what kind of plant they live on. In fact, if you look at insects that feed on plants, 90% of those insects are specialists. They feed on just one group of plants. So I know most of us, when they think, oh, there's an insect on there, it's a pest, whatever, there are very few pest types of plants. And usually those are things were introduced from other places. In reality, most of these insects are specialists on a certain number of plants. And so people worry about these insect declines. And it's true. Yes, we've ruined the habitat for many of them. We built upon them. We've altered the habitat with non-native plants. We have light pollution that attracts many of these things so that they die. But in reality, if we really want to help things out, it goes right back planting native plants that they evolve with, because that is what these specialists need. So if we want to do something about these big insect declines or something, one of the easiest things we can do is plant the plants that they evolve with and they need. these specialist plants. So folks, that's what we can do to counteract what could be a global decline in insects in many different places. At least one thing that we can do. So that's just, something that we can do that we have control over, and that is planting native plants. Okay, folks? And if you notice, I keep going back to native plants because that is one of the big things I want to get across to you. Many of these things are interconnected, and it starts with the plant. So Aldo Leopold, another great naturalist, he said the first rule of intelligent tinkering is don't lose any of the pieces. And the bad news is we're losing pieces left and right. And when we lose enough of them, we cannot form the puzzle again. When we lose too many, the puzzle is incomplete. We lose so many of them, and guess what? The puzzle doesn't exist at all. And that is something we can try to counteract by protecting what we can, and in particular, planting the native plants that they all depend on. Now, I'll tell you what, I'm going to stop right here and maybe take a few questions if there were any, and if not, continue. But again, are there any questions so far, Saranella? Or if not, again, I'll be happy to continue on with the presentation.
What type of question is that? We have questions.
Of course, there's some kind of question. Let's take a couple of them, and then we can continue with the rest as we continue onward. But what kind of question?
Absolutely.
Mhm.
So do you have a source for the species on native and non-native plants? I would love to use that data in my classroom.
So
Danny Moore.
yeah, absolutely. First of all, you can look at Talamy, at Douglas Talamy, and you can look at some of the charts that I showed you, and more modern ones, because as I told you, some of mine are out of date. He shows a lot of the different kinds of plants that you can. The next thing is join your native plant society, whether it's the Maryland one or the Virginia one, whatever the case may be, and they will tell you all about the native plants that you need to. Support those nurseries that grow native plants. In Virginia, a good example here in Northern Virginia is Earth Sangha. A good example over in Maryland, Chesapeake Natives. These are plants that are local. They're not cultivars. They're not clones. These are plants that support many of the other things. And it's much easier to do in Virginia, which I'm much more familiar with, than Maryland. But if you really want to find out which plants are native to your county, you can put in the plant name. There is the Virginia digital atlas of plants, okay? And the Virginia Atlas, I think, if you look it up that way, and you can put in what plant you want to, and it'll tell you, is it native or not native to your particular county? So you can get down to that specific as to what is out there. And then read Talamy, because as I mentioned before, there are keystone species that supply everything else. A good example on the woody plant side is the oak. Look at how many different things, 600 exclusively to oaks. That is a keystone species for that. You go the other way, and I'll talk about this later. You can go with goldenrods, another keystone species which supports a ton of different kinds of things. And that's a keystone perennial and a good fall plant that we should have. And there's so many different kinds of both oaks and goldenrods that you can find one for your particular type of habitat that you have. There are species of oak that grow in dry places, wet places, tall, short, all of these. Same thing with goldenrods. There are ones that grow in wet areas, some that grow in dry areas, some that grow in the shade. There's a variety of different ones you can use, but support your native plant society and support your native nurseries. Okay, another question.
I'm sorry if I missed this, but did you mention a source to learn more about keystone species in specific?
Yeah, so the keystone species, and I forgot the name of it. So Doug Talamy's latest book, in the very end of it, if you have to and you can't read the whole book, go to the very last chapter, and he lists, I think, 15 different things that you can do. And one of those things is the idea of keystone species. He picks I think it's maybe like 10 woody plants that he plants, and he said these are the ones that support the most things. Same thing with perennials. He says these are the plants that support the most. Those are the keystone species he talks about, and he mentions a lot of them. But if I were to go back several slides, that slide basically tells you the keystone species for both woody plants and perennials in his books. But Doug Talamy does spell out a lot of it. So I'll tell you what.
Awesome.
One more question, and then I'll continue on, and we'll take the last of the questions at the very end.
Okay, is the connection between bars and moths particularly partly because many moth species are nocturnal. I'm sorry, that should read bats.
Yeah, and that's definitely the reason. So one of the big reasons, again, we're talking adult moths, is they take on moths, and again, I posted a little bit about this. There's this warfare between moths, an evolutionary warfare between moths and bats, because the moth, of course, doesn't want to get eaten. So many of them have ears, and again, you can tell the different families by where the ear is on the moth. So as the bat goes out there and basically sends out a sonar. Basically, he calls out, and then it bounces back, so you can figure out where objects are, including where the moths are. If it hits and it dings a moth, that moth then it automatically takes evasive actions. Some moths have special scales on their wings which act as deflectors so that they don't bounce back as well. And as soon as each moth at different families have different escape tactics. Some fly straight down, some go left and right, whatever the case may be, because they heard the bat coming after them. And some of them are really neat. For example, the tiger moths. Many of what are white. Why? Because the only thing that shows up at night when these things are flying is white, and so they warn whatever it is. I don't taste good, but they warn another way too. If they hear a bat coming, they basically call back to it. And at first they say, "Oh, these things are jamming the bat signals or whatever it is." In reality, it's not that. They basically are warning the bat, "I don't taste good." So if the bat does capture a tiger moth and eats it, he remembers the sound that it makes. Oh, this does not taste good. And if he's chasing after it again and he's following one and he hears that thing back, it's a warning to him, I don't taste good. Anyway, this evolutionary thing has been going on forever, and it's especially true of bats, of moths, because moths do fly at night. And so that is what they usually try to eat. A moth is basically there's a lot of good protein on a bat, and it supports a lot of different kinds of bat species, although there are specialist bats who also specialize on beetles as well. So let's
Thank
continue on,
you
and
so
we'll,
much.
yes. Yeah, we'll continue on, and I'll take the last questions at the very end, but let me just finish this. You finished just this presentation, and we'll take whatever leftover questions are at the very, very end. So here we go again. So again, I mentioned galls, and galls are basically edible homes, okay? And things that live on, that are gall forming, they basically get onto their host plant, and they alter the way that the plant grows. Many of these, if you notice the gall, and again, there's something like 550 different kinds of galls on oaks, okay? So you can notice the gall, you can tell specifically what kind of insect made it. They're usually what they call centipede wasps. So they're very specific, and not just to what plant they go to, but also what part of the plant. So for example, an oak apple gall it forms a gall only on the leaves of certain types of oaks, whereas in other ones they actually go to the stem, and other ones go to the root, and so forth. So galls are incredibly specific. They're very, very specific to what kind of plant they live on, and then guess what? They also are very specific to what part of the plant. And again, here are several of them. As I mentioned, over 450 different centipede wasp galls, like on the first slide here, an oak apple gall. And then you have a black cherry gall. This is a mite that forms this one, and the mite grows on there and form these little fingers, as they were. And it's really interesting because there are things that basically depend on these. So, for example, this black cherry gall that lives on here, there is a certain kind of azure butterfly that feeds on the cherry gall. So it doesn't feed on cherry, it feeds on the gall. So if you don't have the gall existing on the cherry, you also don't have the cherry azure butterfly. So again, everything's interconnected one way to another. Same thing with this. There's another kind of gall. This is formed by a fungus. This is a pocket plum gall. And then on the right, just to show you how even more complicated again, this is a witch hat gall. But witch hat galls need two hosts. For one part of it, they need, I think it's birches. So they need birches. So if there's no birches in close association with witch hazel, then this animal can't exist, because part of its life the first phase is on birches, and the second part is on witch hazels, and it forms these neat little witch hats, they call, on the end of it. So galls are incredibly specific to certain kinds of plants and what parts of the plants. And interestingly enough, many things then are dependent on these as well. So galls, and again, they don't really cause, a lot of people, I get these calls all the time from master gardeners, things like that. Oh my God, there's this big funny looking thing on the tree. What should I do? Should I destroy it or whatever? And here's the thing. Most of these things are basically just something that maybe you may not like the way that it looks, but it doesn't really affect the tree. If you think about it, these things are evolved together. And if these kinds of galls were to eliminate their only host plant, that would be a very poor evolutionary practice. Why would you kill off the one thing that you need to survive? It wouldn't make any sense whatsoever. So yes, these things live on there, but unless the thing is incredibly weak or something like that, they don't kill it. They're parasites in some ways. They do live on the plants, but they're not going to kill the plant itself. Okay, so that's galls, very important type of thing. And again, we could do a whole new presentation just in galls, but that's a different story. And then something else, and these are vernal pools. These are temporary pools where part of the time they hold water like this, and other times they go completely dry. And you may think, well, what big deal? What is this glorified puddle good for? And in reality, because these things can't support fish, they dry out, so there's no fish, there's no permanent bigger frogs or anything that live on there. They support a whole group of vernal pool species that need them. So here's an example of just some of the vernal pool species that have to have a vernal pool in order for them to survive. Whether it's wood frogs on the top right that live in the woods but need a vernal pool for them to survive, or in this case, spotted salamanders, our largest local salamander. They live on there. They need the local woods, but they come into the vernal pool for them to mate, and even more so, they find it depending on what kind of algae is there. That's another complete other story, but they can smell the algae, they go to it, so it's another connection. Without the algae growing in the vernal pool, the spotted salamanders wouldn't know where to go. Then you have marble salamanders, who, unlike the other ones, nest in the fall. And then you have fingernail clams, which, as you can see on my finger, they're very, very small. But where do they live? They live in these vernal pools. And then over on the right are wood frog tadpoles, but you see those little dots that are floating around it? Those right near are water fleas. Those are Daphnia. And again, these are tiny little things that also need vernal pools to live. And of course, spring peepers. When vernal pools aren't around, these animals don't have as good of a chance of surviving. They will try, but their chances of surviving are very, very limited, especially the top row or whatever of these amphibians. Why? Because they are specialties for fish to eat. And so where there's fish, where there's a permanent pool, they don't do well. And a disappearing pool, that's when they have the best chance of surviving. And that's why vernal pools are important. They're these vernal pool species which are closely associated to vernal pools. So here we go on to something else. And this is kind of a neat story. The West Virginia white butterfly, the thing in the middle. I know it looks like cabbage white, which is an introduced species, introduced in 1860 something up in Canada. But the West Virginia white is our native species, low flying, comes out in the springtime. And on the right-hand side is the toothwort, which is its host plant. So what this butterfly does is it comes over, it sees the plant, and it lands on it. And then it drums. It takes its front legs and drums on the leaf itself. That releases some chemicals, and so they can taste it. This has got, I see, it's got mustard oils in there. This must be a toothwort, and it lays its eggs there. Because if it shows in the right plant, it needs a toothwort to survive. But again, sometimes when you add something to the puzzle, it can affect a lot of other things. On the left is garlic mustard, a much faster growing type of plant, an invasive plant, which is now heading, is really taking off. And the mistake that the West Virginia white does, and again, there's lots of bad things about garlic mustard. They send out different kinds of chemicals in the soil that allow other plants not to survive. There's all sorts of ways that it ensures it survives, but other things don't. Well, in this case, the West Virginia white will land on the plant. It'll drum again with its front legs, taste mustard oils. This is a mustard, and it lays its eggs, except it's not the toothwort. It's a different kind of plant. The toothwort is its host plant. The garlic mustard will poison them. So it lays it on there, and unfortunately, the caterpillar dies. And unfortunately, as garlic mustard has been spreading more and more in the area, the West Virginia white is disappearing from its homeland. Again, only because it's evolved with the native plant. That's what it's looking for, but it mistakes the other one and it dies off. And that's a problem. Invasive plants, there's a lot of different ways that they can affect them. I already mentioned the garlic mustard sends out chemicals that allows, that makes difficult for other plants to germinate. And that's how it protects itself. But in other ways, here it is, the West Virginia white makes an honest mistake and it dies in the process. And that's not, that's one of the problems with invasive plants. Now, oh, I got this out of place. I meant to put this up top. These are the two plants I'm talking about. On the left is the blue orchard mason bee. That's our native mason bee. And on the left is a longhorn Japanese bee, okay? Actually, two of them. You got the male with the white face on the front over a female. And so, folks, I tried to attract the blue orchard mason bee, and I did well the first year and the second year. And by the third year, all the plants were taken over by this other bee, which is not native, outcompetes for burrows for it to live in, and outcompetes it for the food and pollen it needs. And then in the very end, all that I was basically producing was this non-native bee when I really wanted to produce the blue orchard mason bee. And again, that's why I stopped trying to do and raise mason bees. Anyways, so here's another type of thing, interesting story, and this one has something to do with the local area. Okay, so these are African clawed frogs, and African clawed frogs are not, they're not native. They're an aquatic frog. They barely come out. If you look in the back legs, you can see the claws on it, something that other species of other genus of frogs don't have. They're one of our few clawed frogs, and there's about 5 different kinds of these xenopus clawed frogs. Now, they're really cool in aquariums because you know what? They taste bad. They're poisonous. So if you keep them in an aquarium, a fish will bite this. Oh my God, it tastes bad, and they won't mess with them again. So you can keep this in other types of tanks, and that's probably why people bought them. The other thing about it is these guys will eat just about anything. So they can feed on fish flakes and things like that. So it's a very interesting thing. Also easy to breed. People would use this in breeding experiments. So here in Arlington, many years ago, it kind of surprised some people when we found these in 2 of our ponds here in Arlington. Now, big deal, they're African clawed frogs. The winter will come by and that'll kill them off. It's not good to have them, and obviously they're poisonous, whatever the case may be. But wouldn't you know it, that when winter came by, these animals were still alive and they were reproducing. We actually, you could go make holes in the ice, you could find these things underneath there. I'm like, wow, that is not a good thing. So Arlington, some of the naturalists and stuff like Arlington were one of the many people who talked to the state about making it illegal to sell these things, because already we were seeing this was going to be a problem. And the law was passed. Now, people still sell this, sometimes by mistake and sometimes on purpose, but they don't sell this anymore. So flash forward many years, and we find out something else about this frog. And they found out that this frog is likely responsible for a new kind of fungus, the chytrid fungus, which unfortunately is wiping out things left and right. Now, so much so, if you look over here, that this plant, which actually was around for the longest time, but every time people dumped their aquarium water and let these things go, these animals survived. And now we find out that this affects at least 287 species in 37 countries, and already 100 species of mostly frogs have been wiped out thanks to the introduction, this extra piece of the puzzle that should not be there. It does not kill the African clawed frog. It grew up with this, but it's from South Africa. It's not from here. And so the many species around the world in 37 countries that aren't used to it, they are dying off. And that's a very sad thing. Here is a new piece of the puzzle that should never have been there. And when it goes through there, it's wiping them out. In fact, this thing now travels at about 100 kilometers every year. And some scientists now are racing ahead of them. They'll go in one year and they catch as many different things as they can to put in what they call frog arcs, okay? They put in these different places and they try to raise these frogs until they can find some kind of cure for this or not. They go back the next year and it's silent. Again, the silent spring thing, it's not birds this case. In this case, it's frogs. Where there were hundreds of frogs one year, they're all completely dead because in many species is 100% mortality rate. And that's a sad thing. So in some places, these frogs no longer exist in the wild. They only exist in captivity until we find something to do with them. So I flash forward to this. So this is Tuffy. This is the very last of the Rab's fringe-limbed tree frog. Now, this is a very cool frog. It was a gliding frog. It actually could jump from tree to tree, spread out its legs, and it would basically parachute from one tree to another. And it was the only species of frog where the males actually fed their skin cells to their tadpoles in what was a form of parental care. So this Panamanian frog was a really, really cool thing. And guess what? Kittredge came through. They rescued as many of them as they can, and scientists never figured out how they could get these things to breed. They played with the lighting, they played with how much rain, they played with the temperatures. None of this they never happened until the very last one left was Tuffy. And it's kind of sad, but when you actually see a species completely blink out of existence and never be around anymore, but we can point to that. So when this one died on September 26, 2016, the last of its species, we can actually point to when this thing completely disappeared from the face of the earth. Why? Because of an introduced fungus that nobody meant to do, but did. And that's why there's laws out there. Don't release things. Don't bring in, I wish people would plant just native plants as opposed to other things. Now, granted, yes, we like tomatoes, should you plant tomatoes, but if things are known to be invasive, it should not be introduced. And in this case, by accident, people introduced this thing and it's wiping these things out. And this is a sad reminder of how these things can affect other animals. In this case, this whole species of frog with a very interesting, a gliding frog, a thing that formed parental care, is completely gone because we introduced the fungus accidentally in these other types of frogs. So, folks, this kind of leads me to something else, that's biological controls. And everyone says, okay, we don't want to use herbicides, we want to use, let's use biological controls. And it is true, in their own places, this makes sense. There was something that kept these animals and plants in check in their own home range. But when we introduce things that are not originally there, we are intentionally adding another piece of the puzzle. And guess what? Sometimes when you introduce this, it does not have its intended qualities. You introduce this to control one thing, but it doesn't really happen that way. So over to the left, we have the Asiatic, or it should be called the Chinese praying mantis. These are big, they're introduced, they still sell them in horticultural centers. What a terrible idea. For one, this will never control anything. Why? Because they eat each other. So you never have enough of them to actually control anything. And you can't make them eat what you want them to eat. By the end of the fall, these things will eat anything smaller than them. And where do you find them? On flowers, sitting up at the top to nail whatever pollinator comes to eat there, whether it's a bee, whether it's a butterfly. Some have even learned to stake out hummingbird feeders. And occasionally, they'll even kill a hummingbird. This is not something that we should be introducing, and people still sell them, is a bad idea. It doesn't do what you want it to do. And unfortunately, our native mantis, which is much smaller in this, which does not harm all these different things, when you introduce this one, it's wiping out our native mantis as well. Good luck finding in urban areas any of the Carolina mantis, which was our native mantis. It's all been subsumed and eaten by the Chinese mantis. Then you got the Asiatic multicolored ladybug, the ones that are easy to collect because in the wintertime, they all pack together. So it's easy to shovel them into an area and sell them. And again, the same thing. When they sell this thing in horticultural places, you buy them, oh yeah, ladybugs eat aphids. That's what I want to happen. You open this thing up, and because you're hungry, they fly off into all sorts of other places, okay? Not where you wanted them to. And you can't make them eat what you want them to eat. These things are being implicated in the disappearance of our native ladybugs, which they will also eat. And I don't know how many of you guys have ever felt this, but these guys bite. Go figure. They'll actually nip you. And again, these are the ones that in the fall congregate in our homes in big, huge numbers to make a pest of themselves. Why? And then they smell bad because they have what they call reflexive bleeding. They protect themselves by, in the joints of their things, if something attacks them, they release this smell to make them less appetizing to eat. Thus they have the color on them, a warning color. But in reality, if you bother them, they'll release this thing and it'll become a pest in the house. So this thing is implicated in the disappearance of our native ladybugs, and they also eat all sorts of different kinds of aphids and other kinds of things, some of which are useful. But this is what you have because we introduced this. Same idea with this. Gypsy moths, big, huge problems. We introduced the tachinid fly. The only problem is that when you introduce it, less than 5% of what they attack were gypsy moths. Instead, they affected 150 other butterflies and moths and about 50 other beetles. And here you got, look, here's a monarch chrysalis on the right-hand side, and what is growing out of it? Those are arachnid fly maggots that are pouring out of it. So folks, here was another intentional introduction which completely backfired. So people are getting better at it. They're really studying what these things are. But oh my God, every time I hear that someone is releasing a biological control, I cringe because we do not have a good, we have not got a good history of these things working out like we intend them to do. Now, again, they're being much more careful, and the couple that have been released have worked better. But again, we have this history of other things of people introducing a thing to the puzzle. Again, you don't want to lose pieces from the puzzle, but you don't want to add things to the puzzle either. Either way, you don't have the same puzzle. And that's what we're kind of talking about here. So let me go into some very specific type of things. Keystone things. Somebody mentioned, oh, keystone plants, whatever. Goldenrod is one of them. They found that if you look at tall goldenrod, 103 species they found that to just feed on tall goldenrod. A 1948 study found 241 species on Canada goldenrod. So this is a very important goldenrod, goldenrods as a whole are very important. So if you look at it, you find out that a ton of birds feed on it. There's an example of them. Several mammals feed on it. Again, another example of them. This includes all sorts of different kinds of types of other things that feed them, including 13 species of grasshoppers that prefer goldenrods to anything else. And then bees. There are 11 illegal electric bees that without goldenrod, they cannot reproduce. So when you plant this, you're helping 11 different species of bees that can't survive without goldenrods. And then 115 different kinds of caterpillars feed on this that then feed many other types of things. There are all sorts of galls that feed on this. There's a ton of different kinds of beetles. You see just a list of all these things. This is what you call a keystone species. There are some that grow in the shade, okay? Like the blue stem goldenrod grows in the shade. You got some that grow in dry areas, some that grow in wet areas. There are a variety of different ones, but if you plant this, you're supporting a ton of wildlife. This is what Talony means as far as a keystone species. It helps a lot of other things. Another keystone species, and again, we already mentioned a couple of the trees as far as oaks, are asters, another fall blooming thing. Another great thing that feeds a ton of different kinds of birds. 109 caterpillars feed on it, a ton of different bees, including 8 of them, which are legolactic, which means they have to have aster pollen or they can't reproduce. And again, there's 7 aphids, 7 bugs, a bunch of different things. And as far as variety, Virginia alone has 38 species you can choose from. Some that grow in just about every kind of habitat we have, same as the goldenrods. So folks, a lot of people say, oh, they don't want to plant native because there's not enough variety or something like that. It's not true at all. In Northern Virginia, and again, I'm talking Northern Virginia because that's where I work and so forth. We got about 1,700 species of native plants, all of which grow in specific habitats. So there are things that we can grow in non-different places. There is no limitation of the great kinds of neat things that we have. The problem is everyone wants some exotic thing from another place that supports nothing and does not plant the native plants to support everything. So folks, the one thing you can do, plant native plants. So another one, I'm kind of a big thing on edible landscaping, okay? I love this kind of thing. I like service berries. A ton of things feed on service berry, birds, people, whatever. So here is just an example. Here are wild strawberries. That's the thing in the left and in the middle picture. And if you notice where these are growing, that is my driveway. It is growing in the cracks of my driveway. Now, I purposely introduced a part of it there, and that's how tough and hardy it is. Now, these are small little strawberries, but oh my God, they're delectable. My son used to love eating them. Now, I will say between my son, between the robins, between the chipmunks, I get very few strawberries, okay? So it might be edible landscaping, but many other people take advantage of it. And it was really bad when my son taught the kids that this was a great place to go eat. So I don't get them now. I have to compete with the neighborhood kids too. And again, it's a native plant. Now, unfortunately, something that looks a lot like it was introduced, a mock strawberry. So you look at the right-hand side, that's a mock strawberry. And the difference is, well, first of all, the edible strawberries have white flowers. On the left, you can see the edible, the mock strawberries, the non-edible. And again, they're not poisonous. They don't taste good. They have yellow flowers. And much like our strawberries, if you find them, the seeds are embedded into the flesh. On the other hand, if you look at mock strawberries, the seeds are just placed on top of the flesh. And if you look at this great edible landscaping, Fragaria virginiana, 81 caterpillars, 53 birds, and at least 1 bee is a specialist on it. Folks, this is a great plant that's not that picky, that they can survive over there, that has so many added benefits, much like serviceberry, which is another side I wish I'd added over here. So again, folks, a ton of neat things. And with that, there are hummingbird plants you can plant. So again, I know that I'm over time, but a ton of different kinds of things. I invite you to follow me. And if anyone still wants to stick around, I'll be happy to answer whatever questions there still may be. Otherwise, thank you guys very much. I hope everyone has a happy Thanksgiving, and I hope you enjoyed this very short introduction and how everything is connected to everything else in the natural world.
Thank you so much, Alonso. That was a fantastic presentation as usual. And first, I want to read the questions that came through the chat, and then
Sure.
I will open the floor for anyone who will want to ask any other questions.
Okay.
So, starting, we have Suzanne that would like to know. Oh, sorry, not Suzanne, but are carpenter bees the same as mason bees?
No, they're not. Mason bees are called mason bees because they use mud in order to make their nest. Carpenter bees, and we only have, well, here in this northern, there are some in the southern parts, but up here we have one kind of carpenter bee. And again, they are native. They do some, they have a role to play in all this, but they're not the same as mason bees. Mason bees don't make their own burrows. They take over old burrows of other things. Carpenter bees, they will use existing holes, but they will also dig into wood to make their own thing. So they're two completely different groups of bees.
Thank you. Just for everybody's information, the slides of this presentation and the recording will be available to you as soon as I'm able to edit the video. I know I'm a little behind with the presentations, so I really appreciate your patience. I promise I will get it to you. All right. So if you only had a brief opportunity to speak to a HOA, what few pointers would you dwell on? I'm trying to have to pick battles, blowing leaves, chemicals, composting, gardening.
I already mentioned it. The one thing that we can do the best is plant locally native plants, not cultivars, not clones, not nativars, as they call them. Plant locally native plants. Some of the other stuff, yeah, we may be able to work on and whatever, but if we did that, it helps so many different types of wildlife. Plant native plants is the best thing that most of us can do.
Awesome. How do Daphnia and fingernail clams survive when the vernal pools dry?
Though they estivate, they actually go into a dormant state. So it's really cool. So I've actually done this as an experiment. And again, it doesn't always work, but when it does, it's cool. I have actually dug out a small little piece, added water, a dry piece of a vernal pool, dug out a little piece of it and added water. And what do I get? These things back to life. The fingernail clams spring back to life. The Daphnia spring back. The Cyclops, another kind of small. All of these things spring back to life because they can go into a dormant state and they dry out and they can stay in that way for a very long period of time.
Wonderful. A lot of thank yous for you for a very informative talk. Could you please show the hummingbird plant slide again?
Right there, a ton of them, and underneath them, you'll notice I put the number of caterpillars that these genuses supply. So, I mean, double. Yes, you like hummingbirds, but you're helping the insects at the same time.
Thank
Okay.
you. I
You
actually wanted to learn that for my own purpose in my own yard.
there
So this is awesome.
My favorite is trumpet honeysuckle. It's semi-evergreen. It can climb all over a place, and it has one of the longest blooms. I still have this in bloom in my yard right now. It's got one of the longest bloom times of any of our native plants. Trumpet honeysuckle.
Now, and this is a question not from the chat for me. What is the blooming period of the trumpet honeysuckle?
So I've seen mine already start in July, and again, I've had some that just yesterday there was 2 or 3 blooms still in there in my plant. So it it likes to grow late in the summer. So usually we're talking August and September. That's the peak of it. But in reality, I've seen it bloom anywhere from late June all the way now to December. I mean, really almost into December.
Yeah, that's why I'm asking, because I was today at ANS and I
Mhm.
saw it in bloom. I couldn't believe my eyes.
It's incredible. It is incredible. And again, hummingbird plants have the same shape. They tend to be red. Things they don't have a good smell to them, but they also have a long funnel-like look to them. Why? Because that's where the hummingbird can stick its long tongue into.
Great. When should we be discarding our mason bee blocks?
So so we could do a whole thing on mason bees, and there's probably better people. Sam Drogi, for example, probably would be better than me to explain this. So here's the thing: in my personal experience, this is what happens. You can leave them out there, and as soon as okay, first of all, if you leave them for a long period of time, you basically take a solitary bee and you put tons of them together. So in a very few short years, you end up attracting tons of parasites, way more than would normally happen if they had to run, fly and find these individual things left and right. So there's that. And then as soon as they start to come out, you need to discard them and put fresh ones in. Otherwise, the parasites will stay in there, and they'll reuse these kinds of things. So as soon as they start to emerge, you need to either change them out or move them to a different location so that you can put fresh ones up. Otherwise, you will build up a huge amount of parasites that's unsustainable.
Thank you so much. Is trumpet creeper
Mm.
Amis radians the same as
No,
trumpet vine?
no, it's completely different. And again, so trumpet creeper is it can be aggressive, and it takes years for it to bloom. But once it blooms, I had a friend of mine who did experiments on this, and it had, from his experiments of many of these different plants, the highest nectar content as far as how much sugar was in the nectar of any of them. So much so that it is a preferred thing. Hummingbirds love to go to it, but it can be aggressive. It takes a year, it takes a while for it to finally bloom, and there are other types of things to it, but it's not the same thing. It doesn't have as long a blooming time, but again, it's one of the preferred ones because of the high nectar content.
Where can we buy hummingbird plants?
Well, again, look around, and again, you go back to that slide. Again, you'll get a copy of it. These are some of the examples, and lucky of them, many of them are very much popular. I mean, I'm sorry, Columbine is very popular. That is one that's normally sold not because they mean to feed the hummingbirds, but because it's beautiful on its own. So many of these are widely available, but again, check with your native plant societies, the plant sales that they do. And again, I mentioned a couple of native plant nurseries. There are other places that also sell them, but those are the most reliable. Ursanga and Chesapeake Natives in Maryland.
When do mason birds typically emerge in this area?
So it depends on the temperature. So most of the time, the first ones that I see coming out, it's usually the males. They're up at the front. They start coming out in late March, and then they hit their peak in April when almost all of them are active. And by June, many of them are starting to die out. But when those mason bees start to die out, then other things come out, like, for example, leafcutter bees and stuff like that we'll also use now. But they're springtime bees. The peak is in April into May.
Great. Jeannie would like to contribute that native plant nurseries like Earth Sangha, I hope I'm saying that right, Nature by Design, Watermark Woods,
Oh, another great.
um, those are places where you can buy your natives. I believe there's another place called Maryland Natives
Well,
that you can buy your plants from.
yeah, and again, if you do buy from them, please make sure that they're not cultivars. Try to, I mean, this is the thing. We choose what cultivars look like. Evolution and the wildlife chose what the natural true species look like. And for example, there are many kinds of trumpet honeysuckles, some of which are pink and this and that, yellow. That's not what originally would happen. So if you do choose one, please choose the native one. Some of them will work as well as others, but you can gamble on something working, or you can do what's worked forever with wildlife. Choose the native one.
Fantastic. Thank you so much, Alonso. If there's anyone that would like to use their voices or any other questions from the chat, you're welcome to do so right now.
Good seeing everybody. Thank you all very, very much. Good seeing so many of you, and I'm happy you could join me on this one occasion. As most people know, I'm much more of a paper pusher than ever was before, so any opportunity to get out to talk to people, I'm all for it. So thank you.
Thank you.
Thank you, Alonso.
So much.
Take care, folks, and good seeing some of my good friends here too. Great to see you guys. Bye-bye.
Bye-bye,
Take care.
everybody. You're a great audience to have. And thank you, Alonso. We are so lucky to have you.
Posting all this stuff as well.
Happy Thanksgiving.
Happy Thanksgiving.
Happy Thanksgiving, everybody.
Bye.
Take care.